Notion is great. It is versatile, it is fast, it also has AI now. But each letter you write, each task you mark as completed, it has to be stored somewhere. It needs a fast and scalable database system. In this video, let's talk about how Notion sharded their Postgres database to make it faster, better. Alright, let's come to this first. What is sharding? So it's when you have a large data set on a single server and that single server, let's say, is not able to handle the load. It's becoming slow, the reliability is coming down. You can take that large data set and spread it across multiple nodes or multiple physical servers. This is called sharding. And there are many techniques to do it, and today we will see how Notion did it. But before we get started, before we go to the party, let me be a little buzzkill. Sharding is hard. Don't shard your database until you really need it. See, it brings in a lot of complexity. So if you have some problems with one server, it will become 5x when you have 5 servers, and maybe some more than that too. You might think that the read performance is becoming slow, so let me shard it. But try some other optimizations first, like let's say increase the memory for the server, maybe make the caching a bit better, optimize your indexes, optimize your queries, do these other things. When everything other fails, we must go distributed to multiple nodes and we must shard. For Notion, by mid-2020, the product usage surpassed the limits of what one Postgres server could handle. They had massive CPU spikes and the vacuum process in Postgres became very slow. So what is this vacuum process? It's basically when Postgres actually deletes the deleted data, which means it reclaims the disk space for the data that you have deleted. And this vacuum process, when it's going on in the background, it can make your other operations slower. There were other issues as well. When Postgres would stop doing write operations for some time, because it would actually nearly run out of the transaction IDs. You can actually read about this phenomena called transaction ID wraparound from the link that I will put in the description. But it's basically Postgres gives every transaction a transaction ID. And if Postgres runs out of unique transaction IDs, it will wait for some times until some are available. So the first step of sharding is to decide which data to shard. To understand this, let's take a peek behind Notion's data model. See, each entity you see, a to-do list or a paragraph and everything, is called a block. And think like this. One block is like a row in the database. It's not exactly like that, but we can think about it like that for now. All the data in Notion revolves around the block. So it's natural that they would want to shard this data, which means a range of block is in one server, the next range is in the other, and the next range is in the other, right? Now, ideally, we would like to keep the data that would be fetched together on the same node. For example, the data associated with a particular block, let's say the discussions on the block using threads. Now, all this data needs to be joined. So the block data and the discussion data, these two tables needs to be joined at some point in time. So if you have those in two different servers, there would be some network calls to bring them together and then process the data and all these things. We don't need that much complexity, and that would make the process really slow. So what we do is we keep the data associated with each other on the same server. So if I have block 1's text data here, I would have block 1's discussion data on this server as well. Clear? Now that we know what data to shard, let's talk about how to shard it. See, sharding requires a key to shard on. A key would decide which blocks would stay on one node and which blocks would stay on the other. And again, we would define the key in such a way that the data that are fetched together are closer to each other. That means they're on the same server or something like that, so that we don't have to go out to multiple nodes and reach for the data. So they decided to shard by the workspace ID, which is simply the ID of the workspace that you're working on, where all the blocks or all your data is in. So they saw that each block in Notion belongs to one workspace, and rarely there are queries which go beyond another workspace. So rarely there are queries where you are reading data for one workspace, but you join a table from the other workspace as well. So you don't really do those things. They said that the blocks that will be associated from, let's say, workspace ID 1 to 100 will stay on node A. Workspace ID 101 to 200 will stay on node B. That would be pretty good, right? After this, Notion decided on how many physical nodes they want to have their database on. And they decided on 32. So there would be 32 nodes. Did I make a typo here and made nodes as nights? No, this should be nodes. Let me correct it here, right? But each node would have multiple logical shards. So each physical database would have 15 logical shards. I think this is done because when you add new nodes on new physical databases, you can move around the logical shards so that your application does not have to be changed much. I might be wrong, so do correct me in the comments. Now in terms of Postgres, each node has a physical database. And each logical shard is a Postgres schema. So let's say there are 3 logical shards or 3 schemas called schema 001, schema 002, and schema 003. All of them would have a table called block, and block's data would be distributed according to its workspace ID among these schemas and by extension among multiple databases across the network. So now you see that all their data is properly distributed in logical and physical shards. They didn't want to use any managed solution like Citus or something like that. So they wrote all their sharding and routing system by themselves from their core application. And this is called application level sharding. And to clarify, routing means that given a block ID, the application knows which database to reach out, and it just goes to that physical node and reads the data from that particular schema where the data is. So the application is aware how the block IDs map to the nodes and the databases and the schemas and all these things. The application knows all these things. And that's why they have different tables in different shards. Not a single table partitioned using Postgres, because then the application would send the request to the database and the database would route it to the correct partition, and that would be 2 steps of routing. Instead, the application can reach out to the schema directly. Alright, this is how they sharded their data. Make sure to read the blog in the description and you will learn more about how they migrated their load from the non-sharded database to the sharded database, which I didn't cover. So always, for all my videos, make sure to read the blogs that are written by the companies who did this amazing work and share it with us. And obviously, like this video and hit that subscribe button. See you in the next one.